Hello everyone, I'm Jung Chol. Linux cluster on CentOS 6 and 7, Chapter 2, Data Storage Introduction. This chapter will cover this kind of the topics. First one, storage model. Second, volume management. And three, shared storages. And four, NAS and SAN. And the last, the topic will be SAN technologies. Storage model here. So storage model, we can use this kind of the storage model with the application data, BFS, and the file system drivers, and the block device driver, and volume. So in case of the application data like a database or web server data, normally user will use this kind of application data. And the virtual file system means a kind of the interface to handle file system related to system calls for what the kernels. So normally the virtual file system can access the kernel directly to use the file system. File system drivers, normally this kind of file system drivers must be supported by the kernel. So using this kernel, we can make the file system such as ext4, gfs2, NFS, or CIFS. This is a kind of example of the file system we can use by the kernel. And the block device drivers, normally kernel will create this kind of file system based on this kind of block device, such as IDE, SCSI, RAID, LVM, and iSCSI. Volume means it's a kind of logical bounds through the local system like IDE or SCSI, or IP network like the SCSI, this one, iSCSI or the SAN technology. So in this course, we will focus on the volume management. So volume management, what is the volume? Volume means some form of the block aggregations. So many devices, physical devices, can be combined as one by some technology. And this kind of the volume dedicated to be optimized through the low-level the device configuration like striping and the parity in hardware. So striping and the parity is are a kind of the technology can be used in especially the RAID. To manage the volume, normally we can use this kind of two terms for consistent names, LUN and UUID. LUN means the logical unit number, and UUID means universally unique identifiers. So LUN normally can be is a kind of SCSI address used to reference particular volume on SCSI bus. So in chapter 4, I will explain the iSCSI. So in chapter 4, we will use this kind of LUN. In case of UUID, is a unique the 128-bit numbers, and this number can be used to uniquely identify object within especially distributed system. And in case of the volume, there are two ways to access this kind of the storage. That's DAS and shared storage. DAS means the direct attached storage, and this will normally use two types. IDE, SCSI, AT, normally using the bus architectures. And the RAID or LVM use the meta devices. In case of the shared storages, this one here, so device shared storage means the device shared equally and available to many hosts. So in this course, we will focus on shared storage. So here there are two technologies for shared, two types, NAS and SAN. So NAS and SAN means the storage technologies for data transfer. So maybe for data transfer, we can use NAS and SAN. First one, NAS. NAS means network attached the storage. So using NAS, we can transfer file data blocks, and this kind of NAS can be accessed by multi-host at the same time. And the NAS, for the scope of the domain, this kind of domain can be defined by IP domain. For example, for the NAS, like NFS or CIFS, HTTP over TCP/IP. The network here, the IP network can define members. And normally the NAS deal with the files and the records. Compared to the NAS, SAN is a storage area network. So SAN normally transfer volume data blocks, not just the file data blocks. And this kind of SAN can be accessed by only one host at a time. Especially the SCSI is a kind of example of the SAN to work over the FC, mean the Fibre Channel, to use this kind of the command. And in the SAN, normally members define network and the scope of the domain, not IP domain. And the SAN normally deal with the disk blocks, not files. So this is a kind of the concept for the DAS, NAS, and SAN. DAS is an application normally will access the file system directly, and this kind of file system can be consist of the RAID, and the RAID based on this kind of the physical hardware device like SATA, SAS, and FC. The serial attached to the SCSI. This is a kind of the SCSI. Thus, the application of the NAS will access this kind of file system like NFS or CIFS. And to access NFS, CIFS, normally this kind of application must use the network address. And this kind of NFS and the CIFS based on the file system, and this file system will provide a RAID with this kind of hardware, physical hardware device, SATA, SAS, or FC. In case of SAN, application will use the file system directly, and this kind of file system coming from here using iSCSI, FC, the Fibre Channel of the internet. To access this kind of the protocol, we have to use the network address. So this file system already coming from here, okay? The SAS and FC using network address, then application can access this kind of file system directly. So here we can see what to check the example for each network types. Like for the DAS, like SCSI. For the NAS, we can use the NFS and NTFS. For the SAN, we can use the iSCSI. In case of the SCSI, each server can access each the hard disk directly. In case of the NAS, such as NFS or NTFS, normally this kind of the servers can access the file server. And the file server coming from where? This kind of the physical hardwares. And in case of iSCSI, normally this kind of the SAN as a client can access this kind of hard disk for each the servers, but in this kind of servers must use networking to access this kind of hardwares. So here I will introduce some the SAN technologies. So first one, SAN. What is a SAN? SAN means the mechanism to connect storage device to machines, especially using over network. And the SAN can be used to emulate especially the SCSI devices by providing transparent delivery of the SCSI protocol. So normally SAN will use the SCSI protocol to provide their devices. And the SAN normally provide illusion to look like the storage device. And this kind of storage device looks like a locally attached the storage. This is a kind of example. FC, iSCSI, and GMB are as your example of the SAN technology. So from the next page, I will explain this kind of examples of SAN technology. So here, there are 7 kinds of SAN technologies: FC, HBA, Fibre Channel Switch, iSCSI, GMBD, Multipathing, and Network Cluster Nodes. First one, FC, Fibre Channel. It's a Fibre Channel normally provide a common network connection to storage the technology. So to access storage technology, we need to use what? FC. Storage networking technology. This FC will provide what? Flexible connectivity options to storage. And FC normally use the specialized network switches, fiber optic cabling, and optic connectors. So this kind of things: fiber optic cable, host bus adapter, and FC the switching. This is a kind of foundation technology where in fiber channel networks. HBA means the host bus adapters. This is a kind of hardware to be used to connect hostware to the fiber channel network. Normally, many hosts will be connected to the fiber channel network, like fiber channel the switch. And to access this kind of host, we need to use what? HBA. And the HBA is treated like a SCSI adapter by whom? By operating system. And the HBA will relieve the host multi-cluster of data input and output task. So HBA will provide the multipathing to access the physical pathway more than one. So to use multipath, we need to use the HBA. Number 3, the Fibre channel switch. This one. So Fibre channel switch means the interconnected kind of the switch. And this switch will provide the Fibre channel SAN to provide, first one, high-speed non-blocking interconnection between devices and additional ports for scalability. So just we need to add the port for scalability of the Fibre channel by this kind of the switch. Linking capability of the SAN about wide the distance. So even if the distance far away, but we can use Fibre channel the switch for what? SAN. And the fabric the services, normally Fibre channel switch can supply this kind of service like login server, name server, time server, and LS server as well. Types of the switch technology. The SAN Fibre channel, the switch can supply this kind of type of topology. First one, point-to-point is very the simple connection between two devices is very simple cases. And the second, switch the fabric. It means all devices must be connected to one or more interconnected Fibre channel switches. So in case of the simple connection, we can use just the point-to-point. But if there are many devices to connect each other, then we need to use switch the fabric. This is a kind of example as a Fibre channel switch. So this is coming from where? HP. So this one. And this is what the Fibre channel switch from where? The Cisco with 24 port numbers. iSCSI, Internet SCSI. So means this is a kind of the protocol to enable client which can be called initiators. And this one will send the SCSI command to remote storage device. Normally we say this is a target is a kind of the servers. And the iSCSI normally use port number 3260 as a default. And the iSCSI can be used as a low-cost alternative instead of the Fibre channel, because the running over existing the switches network infrastructures. For the iSCSI in Chapter 4, I will explain this topic. GMBD, Global Network Block Devices. In Chapter 1, I will explain the meaning and the concept about the GMBD. So, GMBD will provide the block device access over TCP/IP. This one is similar to in iSCSI in concept, but not as developed actively. iSCSI is developed actively, but GMBD a little bit different. And this one, GMBD specifically, especially can be used for GFS, especially in the absence of the Fabric channel. And GMBD can be used using the client and the server model. So server, the GMBD server normally export the which one? Block level storage from each local DASD. So directly attached the storage devices. Client import this storage selectively. So if the server is for this kind of device, then client can use using the import. So this is a kind of example. So here the storage from using the same fabric, and the GMBD server will use this kind of shared storages to provide this shared storage to where this application as your client, the GMBD client. Normally, I already told you, GMBD normally will use this kind of shared storage for what? For especially GFS2 file system. Okay, MP, the number 6, MP, multipathing. So MP means the multiple paths to access the sham storage, shared storage. And for the multipathing, I will explain and show you how to configure multipathing in chapter 5. And the HP1 network interface gets inactive, then another can provide a path to access the shared storage. So FC, iSCSI, GMB passwords can be by the multipath. So multipath will support this kind of the protocols. Number 7, networking cluster node. So in this course, we will focus on networking cluster node. So cluster heartbeat is impossible to separate for cluster communication traffic. It means normally cluster heartbeat is a communication method between the cluster node. And the services and cluster traffic can be set by the two parties. Public network for the service traffic, especially from the client, and the private network for cluster traffic between cluster node in private networks. And the link monitoring can provoke a failover of a link failure. So normally cluster node must have this kind of monitoring the mechanism to check their link is a failure or not. Networking device must support multicast for cluster nodes. Normally, the cluster node will use multicasting, not unicasting or broadcasting for the intercommunication. So, this multicast address is generated automatically at cluster creation time. Or, if you want to configure this kind of multicast address by manually, then you can configure as well by manually. Okay, this is a kind of the multipathing concept. So here there is a server who want to use this storage, and this server connected to this kind of the fabric channel, the switching here. Okay, two switches, and each switch connected to the switch use this one way, one path, and this one is a two path. So if the server has only one path to access the storage and has a problem, the path, then this server cannot access this kind of storage. So if there are two-way here and here is a three-way, then this one will, okay, server and the storage can be supported by multipathing, even if one path has is inoperative, no problem to communicate each other. Okay, in chapter 2, I explain this kind of things, and you need to answer this kind of question after this chapter. What is volume, and what is different between NAS and the SAN, and what kind of technology can be used to manage the SAN, and what is iSCSI and multipathing. Okay, chapter 3, cluster configuration considerations. It means you need to configure this kind of things before you configure cluster environment. Okay, this chapter will cover this kind of topics, general configuration considerations, and check the comfortable hardwares, enable IP port for cluster services, and IP tables firewall configuration, consideration of network manager, and multicast address. Number one, considerations for cluster setup. Number one, general configuration considerations. Before you configure your cluster environment, you need to consider this kind of general things. First one, maximum number of cluster nodes supported is 16. It means if now using the Red Hat cluster suite, this Red Hat cluster suite will support only maximum 16 cluster nodes for their configuration. So you have to consider now how many nodes you want to use for your cluster configuration and the setup. And the second, only single cluster suite. Cluster is fully split by now, so clusters with multiple physical locations not formally supported. GFS2, normally HA, high availability cluster, does not support the use of GFS2 only for single load file system. So in this case, we have to use like Linux, the file system such as like ext3 or ext4 like this. D, no single point of failure hardware configuration. So normally when you configure your cluster environment, you have to consider single point of failures. If you have only one, this kind of the single point to access hardware, then you have to extend this kind of system. Dual controller RAID, multiple network channels, multiple paths between cluster members and storage, and the redundant uninterruptible power supply like UPS to protect your system from single point of failures. Number 5, each one node can run a cluster service, and this kind of node can be accessed cluster service data at a time to support what? Data integrity. Number 2, check the comfortable hardwares. So before you set up your cluster environment, you have to check your hardwares can be comfortable or not, especially PANS devices, storage devices, and the Fibre Channel switches. And number 3, enable IP ports for cluster services. So if you configure your cluster environment using many kinds of the applications, normally we need to enable this kind of port here, this kind of for this kind of service. CoreSync, CMAN is as a cluster manager, LISI, as this one normally will propagate, update the information to all node in the cluster. And the TLM, distributed log manager, will use this port number, and mode clustered Conga, later I will explain this one too. And the Lucy also, Conga user interface server, will use this port number. RZ manager is a resource group manager, also will use this port number. CCSD manages especially cluster main configuration file using this port number. So if you're using now the IP table as your main firewall, then you need to configure this kind of things. In case of the cluster manager, you have to enable the port number, this one. So you need this one, 54.4, 54.5, using port number and protocol UDP. And in my case, the source IP network address will be like this, 8.0. For the TLM, you have to enable this port number, and for LISI, the 11111, and the mode for mode clustered, this one, 165, 68, and 51. For the Lucy, this one, 80, 84 port numbers. So now if we want to enable, so in my case, I already configure like this. So and MVL, then you can see this kind of configuration. Port numbers here for each the services for especially the cluster. And in my case, I include two network address 10.1.00/16 for the private network address, 192.168.80.0/24 for the public network connection. So these two network addresses will be enabled for clustering service. Okay, number 5, the disable ACPI for integrated fancy devices. It means we need to disable ACPI because if you are using the ACPI and when you disable or turn off the fancy device, it will take more the seconds. So to protect your cluster nodes from the immediate turning off, then we need to disable this service. So here, using the chkconfig del ACPI, or just for each non-neighbor, you need to turn off this service. And if you want to use the graph, then we have to add this kind of option. We are in graph configuration file. So in my case, okay, now config list ACPID. So now each non-label is turned off. So if you want label 2, 3, 4, 5 non-label and have that ACPID off, then you can see this kind of result like this. Or if you want to use the graph, then using this file, okay, here, then you need to add this kind of the options here like this. Then you can disable the ACPI. Number 6, the consider network manager. We need to delete or disable network manager on each cluster node because the cluster nodes do not support the use of network manager. Network manager normally will manage our network IP addresses. So we need to disable because this kind of network IP address managed by the cluster, not network manager. So here, two-way their network manager or using system label non-label 2, 3, 4, 5 network manager will be off. And the number 7, consider multicast address. I already told you about this one. So the cluster node will use this multicast network address for their communication each other. So in the CCS, we need to add the multicast address. In my case, 239.192.0.1 for their communication. And B, enable multicast address and IGMP as well. So for the IGMP, the enabling, we can use like this. IP tables info, the protocol IGMPJ accept like this. So for the network manager, okay, let's check chk config list network manager. So now in my case, all the non-label is disabled. So maybe level 2, 3, 4, 5 network manager off. Then you can see this kind of result like this. Okay, then now, so far you studied the chapter 3. This is a summary. After you study chapter 3, you need to answer this kind of question. First one, what do we need to consider for general configuration? I already explained about these general configurations. and which ports need to be enabled for cluster service. This is very important. Please remember this kind of port numbers. And number three, you need to understand how to disable ACPI for cluster service. And number four, also you need to understand how to disable network manager and why. And number five, which multicast address needs to be used for cluster service. If you can answer these kind of questions, I think you studied chapter 3 very well. Okay, thanks for watching this video about especially chapter 2 and the chapter 3. God bless you and see you in chapter 4.